is we'll start by looking at the things that we were already doing that you should know how to do. Okay? So, I asked you to, I asked you to be able to factorize things like x squared plus 4x. Yeah? And do you remember how to do that?
Yeah.
Okay. Tell me. I think this is where you forgot in your assessment. So there is a common factor of x and x. There is a common factor. Therefore, we can take an x outside of the brackets, and x squared is x times x, and 4x is 4 times x. Therefore, if we take x outside of the bracket, we're left with an x on the inside plus 4. Right? And that's it.
How do you know the common factor?
Because I've taken one of the x's outside. It's a common factor. Remember, factors are things that multiply. So what I do is I look at x squared, all right? I look at x squared and I think, what multiplies to make x squared? X times x, that's what it is, yeah? X times x. What multiplies to make 2x? 4x, sorry. 4 times x. Is there anything in both of those that's the same thing? And there's an x in both, right? So that can come outside of the brackets. So I know that if I do, so now just to show you the reverse, if I expand x times x plus 4, I do x times x is x squared, and x times 4 is 4x. So this is the reverse of this. So I almost have to go, right, what in this can I pull out the other way, yeah? So another example of that would be factorize 3x plus 9. So what I'm looking for is there anything that's in both that I can undo the expanding? So, what makes 3x? X times 3. What makes 9? 3 times 3. So what's the number that obviously came along the lines? The 3. So we can take a 3 outside, and what was 3 multiplied by? X, and what was 3 multiplied by? 3. Yeah? It will be, but don't write it yet. That's where we're going to head to. So we did all this expanding bit and factorising. You'll notice it's what I talk about when I say factorise and we have a single set of brackets, that there's only one set of brackets. Okay? Both of these have what we call a common factor. And do you remember we talked about fully factorising? Fully factorising was when we had to take the highest common factor. So I know in one of your answers, I think it was yours, I can't remember, you did the factorisation like this, but you only partly factorised, you didn't fully factorise. So I give you an example of that would be if we had 8x squared plus 24x, okay? If I asked you to factorise that, and we go, there's a an x and an x, and we write, okay, it's 8x times 8x plus 24. But that's not fully factorised, because what else could also come out? So the x came out as an x in both, but what could also come out? Well, there's an 8. Exactly. Close. 8 times 3. So it becomes 8x times x plus 3. Okay. So x is a common factor. 8x is the highest common factor. Yeah. We then talked about, if I then asked you to factorise something different, I then said, well, factorise x squared plus 5x plus 6, for instance. What's different about this one compared to the other ones we've just been doing? There's 3 terms, and there is what looks like no common factor. All right? Therefore, when there's no common factor, our first thing to try and do is to say, well, that's probably because we're going to have 2 sets of brackets. Yeah. So we've got 3 terms, each one of the 3 terms, and we've got no common factor. Sometimes there's 3 terms and there is a common factor. We could take that out first. That's not this example. So do you remember now? So this is what I think in some of you went straight to this bit. How do I factorise this one? It's going to be an x and an x, because that gives you the x squared. So that times that gives you the x squared. Be plus and plus, because two things multiply to make positive 6, add together to make positive 5. No, most both be positives. Well, when we have to be careful with the way it's going to. So remember, this number is what times what, and this number is what plus what. So 2 and 3. Yeah. So we've got 2 and 3. Now, if you remember, this is why we did it. You remember your grid method, which I did see people trying to use. Okay. One way to think of it is, I know I've got an x squared there, and I know there's a plus 6 down here. So the only way to make the x squared is to have an x and an x. That's why I put those 2 x's in. Now, what are the options for plus 6? Well, it could be 6 and 1, 2 and 3 and so on, but we kind of already know that, well, that's going to be 2 and that's going to be 3. Plus 2 and plus 3 gives me the plus 6. Then I check these 2. So that gives me plus 3x, this gives me plus 2x, looking at that one. And I look at those, and this is why they add to make middle term, because I now add those to make the 5x. So I did see a couple of attempts to try and use that. So remember, this one and this one are the easy bits, that one and that one. But this middle one has to be split up in an appropriate way. And it's determined by what numbers you put here to make this one. So that's why we look at the what multiplies first. And then we had lots of things about factorising that. Now, I'm rattling through a lot of stuff here because we've done this. why did we want to factorise something at all? So actually, we factorise to be able to solve the equation equals 0. On a graph, this is where graph intersects the x-axis. Okay. So do you remember doing all that? I'm going to put a new page. So do you remember what that looked like? When we have a graph, right, that is a quadratic graph, a quadratic graph is a U shape or an N shape, right? So for instance, let's say it does this. The important points that we were being asked to do to sketch our graph was find this one, this one, this one, and the vertex, yeah, because the vertex gives you the axis of symmetry, and it gives you the vertex standing, right? Now, the points that I'm looking at, it was important to find those 2 points, the x-axis intercepts, because that led us to be able to find, like you were just saying, the middle of those gives me the x-coordinate for the vertex. Remember doing that? So we need to be able to find those 2 points. Why is that where it equals 0? Well, because if we look at the y-axis, what is the y-coordinate of both of those points? 0. Okay. So for instance, if I asked you to solve x squared plus 5x plus 6 equals 0, I'm basically asking what x values, this x here, x1 and x2, what numbers is it where it crosses the axis? So we know in this case we're going to have 2 solutions, right? 2 values for x. Now if it looks like that, we can't really solve it without a computer. So what do? We factorise, and we know what the factorised form of that is, don't we? It's x plus 2 and x plus 3. So this time we've now got x plus 2, x plus 3 equals 0. It's the same equation, but in a different form. It's in factorised form. All right, and now do you remember what law we used to solve it? The null factor law. Do you remember what the null factor law was? If 2 things, yeah, good. If 2 things multiply to make 0, we know that they must, one of them at least must be 0. So we can say, well, either x plus 2 has to equal 0, or x plus 3 has to equal 0. Well, what must x be if x plus 2 is 0? -2. What must x be if x plus 3 is 0? -3. So we now know that this number here is -2, and this number here is -3. So that's why we did it, and then we've got other stuff. But I'm not going to re-go through the vertex stuff, because I do want to get on to that. You actually asked this question, Ian, quite early on, and I said, oh, we're going to get to that. Do you remember what question? No, it was like weeks ago. No? It doesn't pop up again, same question. It was a good question. Showed you were thinking ahead. The question was, well, what happens if we can't factorize? Does it always factorize? Yeah, remember asking that? So what if we can't put it in this factorized form? What if we can't use the null factor? So what that means is, in BASIC, we've got something like A times B equals 0. That's the general form. If I know that A times B equals 0, I know that either A has to equal 0 or B has to equal 0. And it doesn't matter what the other one is, yeah? Because if A is 0 and B is 3, A times B is 0 times 3, which equals 0. Now, we just have a case where it's x plus 2 is the A, and x plus 3 is the B, so I've got A times B. Now, in the other form, it's not A times B, it's A plus B plus C, so we don't have the same script. Now, I was just going to go before moving on. If I said to you, solve 8x squared plus 24x equals 0, we would do the same thing, okay? And we would say that, well, factorized is 8x times x plus 3 equals 0. And what would the solutions then be? Well, that would be the A times this would be the B. So it's either 8x equals 0 or x plus 3 equals 0. Now this one we recognise, therefore x would equal negative 3. But what about this one? If 8x is at 0, x has to equal... Nope. This is the same thing. A times b equals 0, so x must equal 0. 8 times what gives me 0? Has to be 0. Yeah. Yeah. Yes. No. So for instance, if I said to you, and I'm going to go straight to the factorised form now. So if I said to you solve 2x plus 3 times x minus 5 equals 0. The solutions would be 2x plus 3 equals 0 or x minus 5 equals 0. Now in this one it's just x equals positive 5, yeah? Because it's just x minus 5, therefore 5 minus 5 makes 0. Well, this one, we have to solve it like a linear equation that you must have done last year, which is I would then take 3 from both sides, gives me 2x equals negative 3, and then I would divide by 2, giving me x equals negative 3 divided by 2. So that would be the other solution. Yeah. So it's not quite as simple as always, it's always the opposite. So again, this one is not A times B until I put it in factorized form. This one I gave you in factorized form, which is A times B equals 0 already. Now we did go through how to factorize into ones like that, but it's definitely more challenging. We used to. The thing is, the null factor law is when two factors. Now factors are things that multiply together, yeah? Now, this form is not two things multiplied together. It's got, that's multiplied, but we're adding. So we can't use the null factor law in that form, we need to put it in this form. Right? But, as Eden says, what if we can't factorise? And that is a situation, okay? So let me go through it. So if you've not quite finished, there is the video, so you can go back. But I would like to put the video in. So if you cannot factorise, so let's say we've got something like x squared minus x, actually sorry, I'm going to do x squared plus x minus 13. So we'd be looking at things that, so if we wanted to solve that, we'd be looking for two things that multiply to make negative 13, but add together to make positive 1. It's not going to happen, right? So, what do? Well, we have a formula. And the formula, you're going to write this down, because it was in the pink box. We're going to use the formula. You'll be impressed, because I can memorize it. X equals, they're the two things we were looking for, x equals negative 2x, yeah? X equals minus b, and you'll ask where b is. What is b? I'll tell you in a second. Plus and minus means we've got to split it at some point. The square root of b squared, there's b again, minus 4 times a times c. So you'll be like, well, where are a and c? All of that gets divided by 2 times whatever a is. Now, where does a, b and c come from? Well, the general form of a quadratic is a times x squared plus b times x plus c. So if we're solving that equals 0, we're basically saying that the a number is whatever we multiply x squared by. The b number is whatever we multiply x by. So let's read it back. So b is whatever we multiply b by. And what do you think c is? C is the number with the sign at the end. So in this case, we have got numbers. So what are they? The no number is a 1. So we are going to replace a. A is going to be replaced with this one. B is going to be replaced by that one, and then C is going to be replaced by that. And we'll work out what it is next time. Okay? So make sure that all your notes are up to speed for next time.